So now we're going to look at the concept of logically equivalent statements. We're going to define what it means for two statements to be logically equivalent, and then we're going to show how to prove two statements are logically equivalent in an example. So I want you to recall one of the activities from the set of in-class activities that you completed back in section 2.1. You looked at the two statements not P and Q and not P or not Q from the last set of activities. And probably the biggest takeaway from that problem is that both statements had the same truth tables, right? No matter the values of P and Q, you had the same values for a given pair of P and Q truth values. And that is what we mean by logically equivalent. So we say that two statements are logically equivalent when they have the exact same truth tables. And another way of saying the same thing is that no matter what the truth values of the variables in the statement, either both statements are true or both statements are false. So let's look at another example. You've done some examples, so you've kind of seen how this goes, but we want to show that P implies Q is logically equivalent to not P or Q, which is actually really interesting because when you were thinking about conditional statements, it probably didn't cross your mind that they turn out to be exactly the same as a particular or statement. Anyway, let's see how we can figure this one out. Well, we've already done the truth tables for the implication, for the conditional statement. Right, so we have P implies Q is always true except for the one case where P is true and Q is false. So now let's go ahead and find the truth tables for not P or Q. And we're going to set up 4 different columns, one each for P and Q, one for not P because we're going to be doing not P or Q, and then one more column for not P or Q. That should do it for us. So of course, for the 2 columns for P and Q, we get true, 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 false, false, true, false, false. We've seen that before. Now we're going to look at P so we can find the what the column for not P looks like. Everywhere we see a true in that column, we're going to turn it into false. So instead of having true, true, false, false, we're going to have false, false, true, true. And then we're going to look at the 2 columns Q and not P, since we're looking at not P or Q. For that one, it's only going to be false if both those columns are false. So if you look at the second row, they're both false, but for the other ones, at least one of them is true. So you should get false in the second row and true in the other ones. And of course, the thing that you need to take away from this is if you look at both of those outputs, for P implies Q and for not P or Q, they have the exact same truth table. T, F, T, T for each one. Both table outputs are identical, which means that the statements are logically equivalent. Okay, so now it looks like you're ready to work on the activities for logical equivalent statements. And actually there's another set as well, more logically equivalent statements, just in case you didn't get enough of those. Those are on the PDF file included with this video.